On today's exciting episode of Geometry, we're going to talk about distance and midpoints. How long until we get there? Okay, so the distance between 2 points is the length of the segment with those points as its endpoints. So we calculate the value of this by taking the absolute value of the difference between the coordinates of the endpoints. The reason we use absolute value is that it's always positive. Distance is always a positive number. So we're going to take those values. Okay, the distance formula on a number line. If P has coordinate x sub 1 and Q has coordinate x sub 2, just means there's two x values. Then the length of PQ or PQ is equal to the absolute value of x sub 2 minus x sub 1, or the absolute value of x sub 1 minus x sub 2. It doesn't matter the order, okay, because we're taking the absolute value. If we get a positive answer at the end of it, we take the absolute value, we get a positive answer. If we get a negative value, we still get a absolute value, which makes it positive again. Time for some example problems. Okay, so we're going to use the number line here, and we're going to find the length of segment BE. Now, the first thing we're going to do is we're going to say that we're going to write it out here and use. So B is equal to the absolute value, and we'll take the value of B, which is negative 6, and E is at 2, so minus 2, and I get here that BE is equal to the absolute value of negative 8, which is equal to positive 8. Now, to show that it doesn't matter the order, if we had done this as BE here, and we'll take this as equal to the absolute value of 2 minus negative 6. And so that value, BE, is now equal to the absolute value of 8, which is just positive 8. So go ahead and work on these next three, and I'll come back to you shortly. All right, so let's take a look at this. AC, we can look at AC. Now, sometimes it just doesn't make sense to go through all this. I can very easily look at AC and count from A, 1, 2, 3, and just write the number 3. Go ahead and count it. Okay, if it's a small value. Okay. CF is one we could count it, but you know what? We probably could just do it faster using the formula. So CF would be equal to the absolute value of negative 4 minus 5, and that's going to be equal to the absolute value of negative 9. So CF is equal to 9. FB is another one here that's probably better for us to just go ahead and use the formula. So FB will go from F here, 5 minus negative 6, which is equal to 5 plus 6, which becomes the absolute value of 11, which is, so FB is 11. Okay, now we have the distance formula on a coordinate plane. If P has coordinates x sub 1 and y sub 1, and Q has coordinates x sub 2, y sub 2, then PQ is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Basically, this is a combination. This formula is derived as a combination between the coordinate plane and right triangles and the Pythagorean theorem. So let's go through this process here. An example problem. So we want to find the distance between C is at -4, -6, and D is at 5, -1. So the way I set this up, I'm going to say CD is equal to the square root, and I'm going to take my x values, -4 and 5, -5, and I'm going to square that, and I'm going to add that to the difference in the y values, which is -6 minus -1, and we square that. So CD is equal to the square root of -4 minus 5. This is -9 squared, plus -6 minus -1 becomes -5 squared. So -9 squared becomes 81, and -5 squared becomes 25. And so my final answer, 81 plus 25, this is the square root of 106. And since this is not a perfect square, and we're going to end up with a crazy decimal value, we're just going to leave it here as the square root of 106. All right, so one of the things you can do here is you can graph it in order to check it. So we go ahead and we have this graph here, and we use Pythagorean theorem, right? So 5 squared plus 9 squared, right? We end up with 106, and CD is therefore equal to the square root of 106. All right, go ahead and do these two in your guided notes. Show all your work, and we'll be right back with you. Okay, so we're going to figure out the length of EF here. So EF is equal to the square root of -5 minus 8 squared plus 6 minus -4 squared. So EF is equal to -5 minus 8 is -13 squared, plus 6 minus 4 is 10. So I got 10 squared. 6 minus -4 is 10. So EF is equal to the square root of 169 plus 100. So EF is equal to the square root of 269. EF. Let's just clean this up here. There we go. Okay, let's do JK now. Okay, so again, JK is equal to the square root of 4 minus -3 squared plus 3 minus -7 squared. So JK is equal to square root of 4 minus -3 is 7, so we've got 7 squared, plus 3 minus -7, that is 10 squared. So JK is equal to 49, the square root of 49 plus 100. So JK is equal to the square root of 149. Okay, next we're going to talk about midpoints. And the midpoint of a segment is the point that's halfway between the endpoints of the segment. So if x is the midpoint of segment AB, then AX equals XB and segment AX is congruent to segment XB. So you can find the midpoint of a segment by finding the mean of the coordinates of the points. And the mean is nothing more than the average. Just take the two coordinates, add them together, divide by 2, and that's how you find the mean. So here is the formula, midpoint formula on a number line. Segment AB has endpoints at x sub 1 and x sub 2 on a number line. The midpoint M of AB has coordinates x sub 1 plus x sub 2 over 2. On the coordinate plane now, because you have extra coordinates, you have x coordinates and y, basically if segment PQ has endpoints at P, which is at x sub 1, y sub 1, and Q, x sub 2, y sub 2, then the midpoint M of segment PQ has coordinates of, we'll call it point M, right? X sub 1 plus x sub 2 over 2, y plus 1, y sub 1 plus y sub 2 over 2. Add the x values, divide by 2, add the y values, divide by 2. All right, so time for even more example problems. Okay, find the coordinates of M, the midpoints of ST, for S negative 3, S is at negative 6, 3, and T is at 1, 0. So all we have to do is to find M. We're going to take the x values, which are negative 6 and 1, and divide by 2. And then the y values, which are 3 and 0, and then divide by 2. So M is located at negative 6 plus 1 is negative 5 halves, and then 0 is 3 over 2. So this is 3 over 2. Now, some people want to use mixed numbers here, and that's perfectly fine. So we would say that M is at 2 and 1/2, 1 and 1/2. Oh, and you know what? Here's somebody sloppy with his signs. So this is negative and this is negative. Ugh. I make mistakes too. So when you do them, correct them real quick. So I wasn't careful with my sign here. Okay, so now you go ahead and find the coordinates of the midpoint of these segments with these coordinates. Do these problems on your guided notes and show all your work. I'll be right back with you. Okay, so let's just, we'll call it M, right? This first one, right? So for 4A, this is problem 4A, right? So we'll say the midpoint is at 5 plus negative 4 over 2 and 12 plus 8 over 2. So M is at 1/2, right? 5 plus negative 4 is 1. 12 plus 8 is 20, divided by 2 is 10. Let's go ahead and do number 4b now. Okay, again, we're going to, I'll just use m again. And we're going to add negative 8 plus 5 over 2, negative 2 plus 1 over 2. So in this problem, m, negative 8 plus 5 is negative 3 halves. And negative 2 plus 1 is negative 1 half. So this is acceptable, or you could put this with a mixed number, so negative 1 1/2, and then negative 1/2. Okay, find the coordinates of J if K at negative 1, 2 is the midpoint of segment JL, and L has coordinates 3, negative 5. So what we're doing is this is a missing endpoint problem. Okay, this is called a missing endpoint problem. Okay, so the first thing I tell students to do here is to just draw a segment, right, and label it. So we've got J, K, and L. So K is at negative 1, 2. L is at 3, negative 5. And J is, we're looking for X and Y. Okay. So what we're going to do here is we're going to set this up. We're going to solve for X, right? So X plus 3, right? So the midpoint values, again, this is going to be negative 1 is equal to this point plus this one over 2. So we're going to multiply each side of this equation by 2 so that we can get rid of this fraction. Negative 2 is equal to X plus 3. Oops, excuse me. Subtract 3 from each side. Negative 5 is equal to X. Do the same process with Y. So Y is equal to, no, excuse me, Y is not equal to 2 is equal to Y minus 5, right? Y plus negative 5 is just Y minus 5 over 2. So we're going to multiply each side by 2, and I end up with 4 is equal to Y minus 5. I'm going to add 5 to each side, so 9 is equal to Y. So J is at negative 5, 9. And there it is, right on our diagram. Okay. So you go ahead and work on these two problems. Put your work in your guided notes. Follow the same process. And I'll be right back with you shortly. Okay. So let's do that first one here, right? So P is the midpoint. So in this, if we draw a picture here, we would say of, so P's here, right? And E is here, and we're looking for G, right? So G is going to be XY, okay? So we're going to look for the X value. So if P is the midpoint, so negative 5 is equal to x minus 8 over 2. Multiply each side by 2, I've got negative 10. Okay, let's label this here. Negative 10 is equal to x minus 8. Add 8 to each side, and I got negative 2 is equal to x. Let's do the same thing for y now. So, 10 is equal to y plus 6 divided by 2. Multiply each side by 2, I've got 20 is equal to y plus 6. Subtract 6 from each side. 14 is equal to y. So for G, for 5a, G is at negative 2, 14. Okay, we have the same process to do with 5b. Okay, so let's set it up. We're looking for x and y values for E, right? So in the first one, I know negative 1 is equal to x plus 5 over 2. Multiply each side by 2, I've got negative 2 is equal to x plus 5. Subtract 5 from each side. Negative 7 is equal to x. In the second part here, 3 is equal to y plus 6 over 2. So 6 is equal to y plus 6. Subtract 6 from each side. 0 is equal to y. So on this problem, point E is at negative 7, 0. Okay, a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. This is called a segment bisector. When you intersect it at a midpoint, that geometric figure cuts the segment into two congruent smaller segments. Bisect means to cut. Thought we were done, huh? Last two example problems, I promise. All right, find the measure of segment PQ if Q is the midpoint of segment PR. All right. So what we know here, we know that Q is the midpoint. Okay, so because Q is the midpoint, I know that segment PQ and segment QR are congruent. If they're congruent, their measurements are equal. Therefore, we can set this up with this equation. 9y minus 2 is equal to 14 plus 5y. So we're going to take this now and let's subtract 5y from each side, and I end up with 4y minus 2 equals 14. Add 2 to each side. I've got 4y is equal to 16. Divide each side by 4, and now y is equal to 4. The question, though, is to find the measure, right? Find the measure, right? So we're going to go back over here, and we have to plug in 4. So we're looking for PQ, so PQ would be equal to 9 times 4 minus 2. So that's going to be 36 minus 2, so PQ is equal to 34. And that's your final answer. All right, go ahead and you guys work on 6A and 6B. Draw a picture. It'll help you do this. So draw the picture, okay? And I'll be back with you in a short second. Okay, so find the measure of segment YZ if Y is the midpoint of segment XZ and XY equals 2X minus 3 and YZ equals 27 minus 4X. So again, we want to draw a picture. So I'm going to draw a segment, right? Okay, so XY is equal to 2X minus 3. YZ is equal to 27 minus 4X. And we know, because we have midpoints, those two are congruent. So we're going to set those two values equal, okay? So 2X minus 3 equals 27 minus 4X. I'm going to add 4X to each side. So I end up with 6X minus 3 equals 27. Add 3 to each side. 6X is equal to 30. Divide each side by 6. X is equal to 5. Okay, so now we want to find the value of YZ. Well, 27. So YZ is equal to 27 minus 4 times 5, which is 27 minus 20, which is 7. Okay. Six B here, we want to do the same thing. We want to draw a picture, right? Find the value of X if C is the midpoint of AB. So we're going to have point A, point B, and point C. Okay. So AC is 4X plus 5. We'll put it up here this time. And AB, the whole thing, is 78. Okay, we got to do a little thinking now. See, if AC is equal to 4X plus 5, now the whole length is equal to 78. So I know I can do this one of two ways. Okay, let's talk about both ways of doing this. This is equal to this. I can label this and do 4X plus 5 over here. So now I would add those together, right? And I would end up with, I can do this two ways here. I can multiply using distributive property, right? I can say 2 times 4X plus 5 equals 78. Or I could have just done 4X plus 5 plus 4X plus 5 equals 78. You're going to end up with the same equation here, which is 8X plus 10 equals 78. Subtract 10 from each side. That's ugly. 8X equals 68. Divide each side by 8. X is going to be equal to 8.5 or 17 halves. Right? You'd end up with 8 and 4/8, which is 8.5. Okay. We could say 8.5, or we could say 17 halves. Okay.